My apologies. This is going to be the second part for lesson 9. Something happened to my laptop that it turned everything off. I apologize that the previous video cut off so abruptly, but we're going to start with the examples then. For each situation, explain whether you think the relationship is proportional or not, and then explain your reasoning. Now, I want to show you guys something. When I give you an assignment and I'm telling you to do certain things, or if the directions tells you what to do, I would like for you to underline or circle or highlight what is it they're asking for. For each situation, explain whether you think there is a proportion or not. So this part is literally asking, is it yes or is it no? Right? It's a yes or no part. Once you answer that part, now it tells you you need to explain your reasoning. You need to tell me why you say yes or why you say no. So, part A tells me the weight of a stacked 8x5 times 8.5 by 11. So basically a sheet of paper, a copy of paper versus the number of sheets of paper. So, let's see if we can make a relationship here. All right. The weight of a stack of papers, like copy paper. Let's say I have a stack of 20 sheets of paper and it weighs 1.6 pounds. Let's use examples, okay? Because it's a good idea to use examples. So let's see if it makes sense. So if I have 20 sheets of paper and it weighs, let's say about, like I said, let's do 1.2 pounds. That means if I was to, let's double that up. What if I end up having 40 sheets? And it weighs 2.4 pounds. So we need to understand, is there a relationship between the stack of paper, the weight of it, and how many sheets of paper? The answer to this is yes. There is a relationship. Okay? So let's do 1A. Yes. Because. Okay? Now, you got to make sure if it represents a proportional relationship, there's got to be a pattern. So if you can imagine, if one sheet of paper weighs like a certain weight, then you put another paper on top of the same exact weight, the more papers you stack on the paper, on paper, the heavier your stack is. So yes, there is a constant weight, so there is a constant pattern, so there is a proportional relationship. So we say yes because for every one sheet, right, that weighs the same, the more paper stacked, basically. So the more paper you stack on top of each other, the heavier the load is, right? And there's a pattern for that, okay? So that one does represent proportional relationship. So now let's look at 1B. 1B says the weight of a stack of different size books versus the number of books in the stack. So we're going to use more of a visualization here for some of us. On this piece, I'm going to show you, I actually have 3 different books. that I would like to show you. Let's say I have this book. Okay? It's a pretty online is trying to load this up. I'm gonna do this real quick. So we have a book, right? A library book. Pretty, a little thick a little bit, right? Let's say this weighs about 2.5 pounds. Okay? Now, if I have my teacher planner, this really big planner, right? Super thick, lots of pages. It's a little heavier because the paper in here is a little thick. I stack it on top of that small book. This is not the same weight as the smaller book that's underneath. All right? Now, what if I take your workbook? You already know your workbook is pretty bendy. It is a little lighter than this planner, but not as light as the library book. That's a different weight. So I want you to understand, you can always visualize this scenario. So make it make sense. If each book is a different weight, that means there is no way you can get a constant pattern between the weight of any different size book and how many books you stack it on top. So this one is no. This is a no. No. Now, what gave it away though? No, because of this piece. The fact that it said the word different lets you know. No, because each book is a different size. All right? Meaning the weight is different every time. All right? So I want you to understand that. There's a difference between 1A and 1B. Okay. I'm going to go down to 2 real quick. So for every package of a certain toy also includes 2 batteries. All right. So each package of a toy, 2 batteries. All right. A, are the number of toys and the number of batteries in a proportional relationship? And they're saying if so, meaning if I'm saying yes, what are the 2 constants of proportionality? But if it's a no, you need to explain your reasoning. So, I need to read this carefully because the scenario in the beginning told us what it was. Every package of a certain toy includes 2 batteries. Keyword here is every. That's all packages so far, right? Are the number of toys and the number of batteries proportional? They said for every package of a toy, for every 1 toy, it has 2 batteries. So for instance, if I have 1 toy in a box, it has 2 batteries. What if you have 2 boxes now, because there's 2 toys, that makes 4 batteries. So, is this a proportional relationship? In this scenario, yes. So are the number of toys and batteries proportional? You need to say yes to answer that first part. So yes. And then they say if it's yes, what are the 2 COPs? We're not looking for 1, we're looking for 2 because we can rewrite this 2 different ways. I can write it as however many toys per 2 batteries, how many batteries per toy. So scenario 1 can be 1 toy per 2 batteries, right? 1 toy per 2 batteries. And we know we usually write that as a unit rate anyway. Or scenario 2 could be how many batteries per toy. So I can say 2 batteries per 1 toy. My constant will be 2 different numbers though. Because of that, using T for the number of toys and B is the batteries, we're going to write the two equations relating the two variables. So, they already told me one of them has to be B equals whatever. T has to be what equals whatever. So, this means batteries equals whatever that magic number is times T. That means one of these scenarios aligns with this one. In this case, it aligns with scenario 2. Because if I simplify this, I do 2 divided by 1, that's 2. That means your magic number is 2 batteries per 1. So that means if I have one toy, which is right here, you end up getting 1 times 2, which is 2 batteries. What if I have 2 toys? Well, 2 times 2 makes 4 batteries, but we did that here. So your scenario should be B equals 2T. That's in terms of toys. But now I have it flipped. This will work in favor of scenario 1. Which again, this wouldn't really make sense and it's not realistic, but for value purposes, this is why we're going to work it out. T needs to look like K times B, meaning however many batteries times that magic number should give you the number of toys. So, we knew here, here technically, one toy gives you 2 batteries. I need to know, what if it was 1 battery though? And 1 battery. So technically I should have done 1 divided by 2. Well, 1 divided by 2 is 1/2, which is the same as 0.5. Meaning, half of a toy, which again, that doesn't make sense, right? As realistic as it sounds, half of a toy times 1 battery should equal that. I mean, that doesn't make sense. So now if I put in 2 batteries, B is 2 batteries times your 1/2, that gives you 1 toy. So you should have T equals 1/2 B. Now at one point, one of the lessons shows us how to interchangeably go from this equation to this. And I can tell you now, you can go from this equation to this. You can go interchangeably. They both mean the same thing. You're just reading it differently. So that is all for lesson 9. Again, I apologize for 2 videos because of the cutoff the first time. Hopefully it doesn't happen again for the rest of the year. Take care, everybody.